Hello, good afternoon, everybody. My name is Raul Olivares, and today I'll be walking you through a physics equation. So in this equation, we have a 25 kilogram box is pulled across a frictionless flow by a rope that is inclined 30 degrees above horizontal. The tension in the rope is 50 newtons. How much work is done by the force in moving the crate 10 meters? If the box started at rest, what is the final velocity of the box? Here we have two things that they're asking us for. They're asking us for how much work is done by the force in moving the crate a displacement of 10 meters will be the first step of this problem. And then the second step, and the second thing they're asking is, if the box started at rest, what is the final velocity of the box? So we'll start this how we start all our physics equations. We write down all the variables that we know. So here we know that a 25 kilogram box, so that's the mass. Mass is 25 kilograms. It's pulled across a frictionless flow by a rope that is inclined 30 degrees. So we know theta is 30 degrees. The tension in the rope is 50 newtons. So we know that the force is the magnitude of the force is 50 newtons. We know that the crate gets moved 10 meters, so the displacement is 10 meters. We know that the initial velocity of V naught is going to be zero. What we need to find out is the final velocity, and we need to find out the work that's done by the force. So to do the first step of this problem, we need to use the work equation, which states work is equal to the magnitude of the force by the displacement times cosine of theta. So the next step is we substitute the variables we know into the equation. So work is equal to 50 newtons with the force times the displacement, which is 10 meters, times cosine of theta, which is 30 degrees. So once we type this into our calculator, we get that the work is equal to 433 and some other decimal points that we're not too worried about. We need this rounded out to two significant figs, so that's why we eliminate the rest of the decimal points, because we really don't need that. And we'll make this equal to 4.3 times 10 to the second power, which is scientific notation. Joules, which is the unit we use for measuring work. So it's 4.3 times 10 to the second power joules. Let me put the J right here. So we have the first part of the equation. Please forgive me, I think my marker's running out of ink. But the second step would have to use the work energy theorem, which states that the change of kinetic energy plus the change of potential energy equals work done by non-conservative forces. In this specific problem, we don't have no non-conservative forces. We don't have either gravitational potential energy or spring potential energy, so we can eliminate that. Then we can just say that the change of kinetic energy is equal to the energy in this specific equation. The change of kinetic energy is written as 1/2 mv squared minus 1/2 mv naught squared equals E. So in this problem, it states that the box started at rest, so V naught is eliminated. We don't need that. So we can rewrite this as 1/2 mv squared is equal to E, the amount of energy. Now we use some algebra to change everything so we can find out what the ultimate value of the final velocity is. We start this by eliminating the 1/2 by adding a 2. So we times the energy by 2 is equal to mv squared. We can eliminate the mass out of the equation. Well, not out the equation, but out this side of the equation by dividing 2 times energy divided by the mass. And that gives us V squared equals 2E divided by mass. And we can eliminate the square by getting the square root of this. We'll put that here. So V equals the square root of 2E divided M. Then we'll plug in the variables that we already know into this solution to get our final equation. So that would be V is equal to the square root of 2 times the energy, which is 433, of mass divided the mass, which is 25 kilograms. And when we type this into our calculator, we get that the velocity is 5.8855 and some other decimal we don't need. The rest could we'll round it up to 2 significant figures, which is 5.9 meters per second is the final velocity.